day that we're going to talk about this. There's basically one thing that we need you guys to know, and that's basically how this will be presented to you on your CRCT for rotational symmetry. The question that you guys will probably, it's likely the way that it will be presented to you, does this shape have rotational symmetry at, and then they'll give you a degree measurement. So this is a shape that we've obviously already talked about, equilateral triangle. So basically when we're going to take this and we're going to rotate around, we know that we can move this anywhere we want, right? But the question that this is asking is that once we rotate it, does it look exactly the same as it does where it started? Well, before you guys all say yes, we know. I know what you're thinking of. You're thinking, is it congruent, right? And we know that even if I move it here, even if it turns a little bit, it's still congruent, right? Because we talked about it in translations. It doesn't change size or shape, right? So it's still going to be congruent. But the thing that we need to see is that once it turns, if we were to translate it, remember, if we're just going to move it back on top of it, will it match up perfectly? Is there a time that it will?
Yes.
Do you guys know when it is?
360.
Okay, 360, that's good. I'm glad you guys got that one. So when it goes full circle, it'll come back around. Will it happen anytime in between 0 and 360? You think it'll happen at 180?
Yes.
Let's see. Just real quick. Okay, so here's 180, right? So we already knew it was going to come down to this area, this quadrant, around this point, right? And 180 turns going to flip it upside down. Now, if I take this image, Edward, since you decided it was going to be 180, if I take that and I move it exactly as it is back on top of that, will it look exactly the same? No. Do you guys think that it will at some point, though? Still the same question. Yeah? All right, well, I'm going to tell you guys when it'll be. Basically, if it has 3 sides, it'll be at a third turn, which for this shape, we're going to see that happen at negative 120. So right here, at 120 degree turn, we see that if I move that back on top of our original image, will it be the same? Yeah, it looks exactly the same as what we started with, right? So the other spot that a triangle will happen is at negative 240. 240, I should say. 240, yeah. So same thing here. This looks exactly like our original image.
Yeah.
And I'll go ahead and tell you guys, with a 3-sided figure, it'll happen 3 times. Once, twice, and then again what you guys first said, which were all right, 360. Okay? Now if I were to give you a square, how many times do you think that we'll see the rotational symmetry? 4 times. Great. You guys are there. So this is going to be my best efforts with drawing a square. I know my triangle was perfect. Because awesome. So that's as good as it gets. Let's pretend that it's a perfect square. Okay, let's all use our imagination. Okay, so if I take this, who thinks they can tell me where the first rotational symmetry will be? Yeah, Hicklin.
What you mean, degree?
Yeah, what degree turn do you think it'll be? It happens 4 times. 90? So we'll try 90. Negative 90.
Oh.
Got the point. So there, so at 90 degrees, and again, remember we're pretending that this was a perfect square. It's a little off. If we were to take this and move it back on top, would it be the same?
No.
Yeah. We gotta use our, this one, here, I'm gonna try to fix it just a little bit. That's close. So if we were to move it, great, thank you. If we were to move it back on top, right, would it be exactly the same? Do you guys think it'll happen at maybe say like 45 degrees? Happen in between?
No.
Who thinks it will?
Well, yes. What?
At 45 degrees we'll have rotational symmetry. Who says it won't?
Wait.
Because
Who's still thinking?
Well, yeah.
So you're saying any way you turn it?
Yeah.
Hold on. that it won't because he says the corners will still be out. What do you think?
But I think it will because it's a square.
So
So all sides equal.
So you're saying it's a square. So at 45 degrees, where will this be?
Like right,
It would be like right between the
Right here, right?
Yeah.
No.
Is it still gonna look like? Is it just gonna move exactly as it is as it goes around, or is it gonna turn?
It's gonna turn. It's a turn.
So is it gonna turn?
What's the
Is it gonna
diagonal?
turn?
What's the
Yeah.
diagonal? The diagonal is it? I thought glass.
Where
Oh,
are you
it's not on
45?
square. Oh, so no. What?
So it's an eighth of a turn, right? So look at it. So look at it. So it turns some. So now the points are up and down, right? So if we put that back on top, will it be exactly the same?
Yeah.
So the question is, same question I'll ask it to you like it would be presented to you guys. Does this shape have rotational symmetry at 45 degrees?
No. No. What?
No. No. You're just conforming? The question is, does a square have rotational symmetry at 45 degrees?
No.
No. Because this is it at 45 degrees, right? If I put it back on top, it's not the same. Does this shape have rotational symmetry at 90 degrees? Yes? Because if I take this shape and put it back on top, it looks exactly the same, right?
Well, I think it's that shape still the same size because you know how you did the first time.
If I rotate this around this point, hold on. That's a good question. If I rotate this around this point at any time they come in, does it ever change size or shape?
No,
No.
yes. No. Oh,
Does?
size, no.
Size?
Yes, no. No.
No, it does not. Remember, that's one of our rules of translations. That this will never change size or shape. It's just going to turn as it goes around this point. So this will have it at actually, remember we said it'll have it 4 times, right? So, David, you think you can tell me when it'll happen again? 180? Alright, we're gonna have an extra spot. It's gonna look a little different. Give me 180. Ignore this part right here, okay? Just ignore that. Copy that. So, as David said, does this shape have rotational symmetry at 180 degrees? Yes, it does. Because if I take it and move it back on top of this, so can anyone, without me doing it, can you guys figure out what the last one will be?
What?
270, right? So, one more question for you guys before we move on from this. Is there a shape that you guys can think of that will have rotational symmetry at every single degree?
Circle.
What do you think?
Circle.
Thank you, Austin. A circle. Can anyone kind of imagine why? You guys see that? Right, so any way that you turn a circle, does it still look the same?
Yes.
So we'll just see it real quick. We'll just do like a couple quiz.
Well, he didn't draw it.
So anywhere I put this circle, it doesn't matter where. Some smart boys are just ones out of it. So anywhere I put this circle, anywhere I go all the way around, it could be, what if I did like 45.72 degrees? Still be the same, right?
Yeah.
So do you guys think that you can answer this question? Does this shape, and we'll give you a shape, have rotational symmetry at a specific degree turn? You guys think that you'd be able to do that? A little bit better than maybe 5 minutes ago when we first started this? Good, I'm glad. We'll move on. Thank you guys.